All right. So next, take a look at how to set up the system. So it's a kind of modern kind of the integrated development environment, so to speak. First of all, make sure that you are on a directory that you can write on. So if it's on the root of your user directory, usually you cannot write anything there. So make yourself, for example, under documents, a directory, working directory yourself, and go there. If you need to basically create directories, you can do it here. Make directory, for example, exercise 1, and it's here, and then you can also go cd exercise 1. Okay, so it's quite similar to Unix systems. Have you got any Unix system course? Are you running Linux? Okay, excellent. So basically, this command line system resembles the Unix or Linux because the MATLAB is product of 80s, from 80s. Okay, so working directory, file browser. The next one is Workspace. Here, I have one. Wow, I have one variable there. So on the Workspace, you can see all the variables. So basically, not much to use there, but basically name. If you do not, if you make calculations and forgot to put the calculation result somewhere, basically it always goes to uns. So that has the last answer stored on uns automatically. Sometimes it's a lifesaver. Okay, this is command line driven. No objects here. So it means that whatever you want to do, you have to type it. Nothing is done automatically. And when you have done it here, next command can override it. So it's a kind of sequential machine, not like in some environments when you put these commands, then basically the engine itself kind of plays lottery which one to do first and so on. But not in this one. It's totally sequential machine. Command history is a good way to basically keep in track what has been done. All right, so everything happens on the command window. Or you can also use the editor, command editor. But I will show you how to use it later on. You can find some documentation here on the third tab. And then are some extra windows also. Those are probably the most important places. And here you can click whatever you want to see or not see it. And then, of course, if you mess up everything, you can always reset default window layout. That's the most used command. Okay, so the workflow. Let's see. Yeah. Let's set up a couple of things. A couple of commands. Say pkg and list. That's probably empty for you. Doesn't show anything. You need basically this control and signal, but for that one, let's take the help on package command. So practically, oh, okay, that was a long one. We need to install those things, but let's see, Forge. Yes, For the first time installation of any package, you need to do it like this. Package install, for example, control, and then dash forge. I already have it, so run that command on your command line. Package install control package from forge. I will put this one as the if you put a percent sign, it basically the rest of the line is the comment. I have it already installed. And next, package install signal. By the way, did it work? Package install control. So those commands without the percent sign, of course. Package install control dash forge. Did it work? Yes, it worked. Don't put the percent sign. Leave the percent sign out from the beginning. Oh, you already have it. Excellent. So you got probably a different distribution. Oh, wow. So which distribution did you actually put there? The top one? No? Wait a minute. Oh, you already have it. Let's see, signal is there. Yes. Excellent, excellent, excellent. So it was on the latest installation. So just in case they are not there, you need to install them separately. But it seems that on that distribution, they already were there. That's nice. That really takes lots of trouble out of the business. Okay. Because if you install new packages, you also have to package load them separately. Package load signal and package load control. If they are installed and loaded, that's okay. But that's something for Octave. It's basically produced by a bunch of geeks. So of course there's some hard work there. It's like IKEA furniture, some assembly required. But after this one, this environment is set. Okay. Next, let's test your graphics. Sometimes the graphics actually have some issues. One way to test the graphics is say plot rand n1 100. We basically plots 100 random variables, normally distributed random variables. And it should plot something. If it does not, the first time you use the plot command, it might actually take for a while when it tries to optimize everything. But if it doesn't do anything, then you need to change the graphics adapter. Does it work? Excellent. How about here? Control C. Couple times. No. Yeah. Random numbers. Did you get the? Oh, you got something. Yeah. Close it. Kill the process. Kill. Yeah. If you had the installed already there, then that's yeah. Yeah, that's the way to do it. Yes. Kill it good. Yeah, you do the same thing, hey. Use the Octave GUI, graphical user interface. That one. This worked. What happened? Oh, that's the. What happened? It was working already. What did you do? Reboot. Reboot the computer. It might actually have something to do with it. Yeah. Don't laugh. It will happen to you. Yes. No. So, what is math under? You find. Okay, now it's on the top. I'll open. No. So somehow hanging there. And okay, up a little bit. No, it's not there. Okay, so in that case, it should just open again. Ha! So what is different here? Good. Yep, it worked. Don't do anything now. You put the plot run n 100 there on command window. Run, not run. R-A-N-D, and yes. 1, 100, yes. Yeah, the graphic works. Excellent. Okay, let's see. Do you have the so? Okay. Yes, it was the yep. Just put this package, not package, but put the plot run n 100 there. Nothing else. Oh yeah, documents under go to under. Oh, not a good idea. Not a good idea. Yeah. Do not use any cloud drives for that one, since there are some big synchronization issues, especially with the OneDrive. Yeah. The same synchronization issues as the OneDrive has overall. They actually make usually these programs to crash. So use the local disk. Okay, good. So then test that the plotting works. Plotting works, right? Good. So basically next we can go to the exercise 1. That we'll do together somehow. I don't know why. Exercise 1. Exercise 1. And for that one I will get from this web page. There's for all of the exercises there are templates and return forms. And open the template, and all of you probably has a Google account, right? Open it and put it on your own Google Drive. make a copy to your own Google Drive. So this is just a template, which could be found from here, from the web page. Under Signals, there's exercise 1 template. Yeah. So exercise 1. So basically, the answers go into those boxes, but only when you have made your own copy. So there's one has opened it yet. Make your own copy to your Google Drive, personal or school Google Drive if you have any. Okay. So on here, basically, when you do first you need to make a copy for yourself. Then you can start editing it. Got it? Not yet. So template can be found from here on the web page. Signals, exercise 1 down there. Click on template. Template gives you this kind of file, and make yourself your own personal copy. 2 still missing. So you have your own copy now. Yeah, good. So do you have your own copy yet? Oh no. Under data here, copy. Did you click that one? Data. Copier. Copier. Yes. When you click there, make a copy, basically, then you have an editable copy of that file somewhere on your own Google Drive. Got it? Good? First class? 9? Oh, shoot, yeah, that's the normal. Yeah. Oh no. Oh no. Yes. Yeah. But that's because you're half robot, right? Yeah. Got it? Not yet. Uh-huh. You don't remember your password. Oh, you got the activation key from. Okay, good. If you want to, you can use MATLAB, right? Yeah. diginatives, you know. I'm an old geek. Got it? Not yet. Working on it. Okay. You can also download it as a Word document, edit, and then afterwards, you know, when you have the Google Drive working, then yeah, yeah, download as Word document. Then you have editable copy. Afterwards, you can play more with the Google Drive to get it there. All right, so we have editable copy now, and what you can do with the editable copy, first thing is you write your name. This can be done also in group work, but since we have only 5 of you here, so I recommend you take your own individual stuff there. Okay, so basically, how these exercises go. The first one we will do together, but basically they all are more or less like that. So there are about 10 different questions, and the questions, and then that yellowish area is for your own answers. And the first question, this is an example row. Write your answer. So basically, if you copy paste this one into MATLAB or Octave. It doesn't paste. Oops. Oh, yeah, here. There. Now I have created a variable OO, which is basically values ones. Okay. So if I want to take a look at what they look like, then there's also this nice tool to check the variables. Variable editor. I will put it here. All right. Okay, so that was tested. And then there are questions like, create an index vector from -4 to 14. What? Strange. Where? Okay, yeah. It wasn't me. Strange sounds. Usually I actually do some strange sounds, but you know, then you recognize it's me. Okay. Right. So basically create an index vector. So the first exercise or question is about how to set up for a sampled system. How do we set up the sample points from -4 to sample points up to 14. Basically, this is the n. And that will be something that we can use, for example, as a vector for generating data. So how to tell MATLAB, okay, we are interested on that region. So this is one way to do it. All right, so for example, have a variable named n. Avoid single letter variables, always, in any programming language. In MATLAB, it's especially the dangerous, since you can easily overwrite I and j. Then you don't have any imaginary unit anymore. And the answers are funny. Okay, so at least 2 letters for the variables. So index nn equals, all right, so That's how to generate. You can actually do it like this, and so on. But this takes a while to write it. So easiest way to generate data is using auto-indexing like that. From -4 to 14. That's the syntax. So colon operator. So colon means from to. And without semicolon, it actually shows you the result on the screen. Okay, so that would be the answer for the first question. Control C, Control V. There we go. Next question was about using the previous vector to generate unit impulse function, meaning that generating impulse function, meaning the delta function, which is 1 when the n equals to 0 and 0 otherwise. That's the delta function, and we can use direct the logical operation here. For example, like this, dd equals, we test if n is equal to 0. The logical tests and other tests and everything actually is exactly the same as in C language. So if you have single equal sign, it's setting variable, but the double equal sign is checking if it's equal to. There. The result of this one would be logical, true, false. For that reason, actually, it's safer to typecast this one to double. So testing if index is 0, typecast to double precision floating point. MATLAB or Octave can use also these logicals as ones or zeros, but on the other hand, in C language, true is actually not 1. True is everything else except 0. Okay. Yep. So we got the, let's see, what does the ID look like? Okay, it looks quite okay, but to make sure that we got the correct kind of picture, so what I'm expecting to see is actually something like that. A signal which is truly 0 here and then truly 0 there and then 1 there. So seeing is believing. We can stem plot it. Stem NNDD. Oops, comma, DD. Stem plot for basically small number of data. So number of samples. So use stem. And it looks like that. Okay. Yes. It does something else. Ooh. Double. Oh, yeah. What did I tell you about the equal sign? Yes. Testing, logical test. Logical test. All right, so we have a nice picture of, and it looks like more or less what I'm expecting to get. See, I think we already have some answers for the exercise sheet. All right. Ooh, use the previous vector to generate unit impulse function with pre-sample delay. Okay, sample delay. Wow, that's not yet. So I need to actually have a function which is delta n minus 3. Any suggestions how to generate that? What is the easiest way of generating this delta compared to that one? Do we need to touch the data itself, or is it actually easiest to just use that formula but for n minus 3? Right? So dd3 equals double n minus 3 equals to 0. So this is the 3-time step delayed the delta. Okay, the arrows up and down give you the previous the commands. They were, oops, what is that one? Unit handle. Why it doesn't work? There we go. I have no idea where this invalid handle came from. Someone lost the handle for the graphics, maybe. Okay. That's how you do it. One, two, three. Otherwise, it's the same. Got it? So the correct answer for the for that exercise question is that one. Stem. Yes. Then unit step function. Any suggestions how to generate the unit step function? Unit step function, if you remember, was simply step function equals, or actually step function equals to which 1 when n is greater than equal to 0 and 0 in less than 0 for negative values. So how to, this you should be able to figure out yourself from the previous. Double. Okay, and then you have something n something 0. So what is the comparison here? Greater than equal to, right? Then it should give you the step function. Last plot, this one. You don't. Why? I also got a funny invalid handle there. Show me. Or okay, take a look. Look. Yeah, that's strange. Write close all and do it again. So close all closes all graphic windows. It has something to do with the graphics now. It has some issues with the graphics, but not this kind of issues. So this is a new feature. But this is version something like 2,000 distributions have been done before this one, and now they have changed it a little bit again. Okay. So yeah, so that's the answer, and then oops. SSE. Oh, SSE is already there. Stem. Ah, there. See. Very strange. Okay. So your unit step function should look like that. And again, copy paste. All right. So next question is use your index vector on question 1 to produce sample data vector of sine wave. So how to produce a sampled data using index vector when we have basically the sampling of x function x of t equals basically, well, actually, not like that. X of n is simply x of n times ts. That's our index. One point of interest now, we have the vector, index vector there. And we have sampling rate of 1,200 and amplitude of something. Okay, so our x of t equals 0.4 times sine of 2 times pi times ohm, f equals signal frequency. Okay, the signal frequency here, that's the SSS. You take your student ID number, whatever that is. Lots of digits, maybe more like that. That's an arbitrary number. But this SSS is the last 3 non-zero digits. In this case, it would be 481. So you use your own student ID number, 3 last digits, non-zero digits, and use those numbers as the arbitrary number there. Okay. Times NTS. N times TS. TS is also 1 over Fs. Okay. Something to calculate again. So one way of actually doing that kind of sample, see, we index we already have. let's see, we have the fs equals 1200 sample rate, which means that our TS sample time is 1 divided by fs sample time. Okay, and then we have the n already. What else? We have the SSS. Use your own numbers. I use 1, 2, 3. Use your own values. Okay, and then we can actually generate the sample sinusoid values. XX equals amplitude 0.4 times sine tau times the pi is just simply pi. 2 pi SSS times n times TS. So that's the sampled sinusoid. There. And again, something to copy paste to the here. The next one. How to generate something like that. We have the unit step function, we have this previous sample sign, and we have the delta function. And there's a basically amplitude modulation here. So basically how to start a signal at certain time. Well, we actually multiply with correct envelope, and that will be the unit step. Then the signal starts at time 0, not before that. Sinusoid, if I plot it there, the basically it has also the negative values. Let's see if I can plot it. Stem NNXX. Okay. So how to make a signal to start at certain time? Well, you turn it on with this with unit steps. Okay. All right. Let me see. Okay, that was the signal sequence. Just a comment. This should be generated. SN is there. Yeah, my XX there. So I will just YY equals. Oh, okay. Yeah, well, I can do everything on one line. So unit step function. We already generated that one. The step function was SS. Okay, now actually when you do a modulation, meaning multiplication of signals, you don't do it with such a simple multiplication operator, since this is matrix calculator. If you try to multiply two vectors, they should be, correct form. It's matrix product if you put just simple product there. But with dot times, that's the cell-wise product. So element-to-element product, meaning modulation. So that dot before any operator actually makes this operator a cell-wise operator. And now we can actually multiply that with the previous x function. So yeah, that s was actually the x. Plus 1.4 times, okay, we have delayed delta function nn minus 2 equals to 0. It might actually work like that. We'll see. Typecasting may be needed. in principle, you shouldn't multiply logical values with any real values. Bad habit. Okay, so that's the answer for the next question. You write the comments. And then stem plot the previous data vector. Well, let's do it. Stem n and yy. There. So my sinusoid starts at 0, and then it has this peak due to this 1.4 times the delay delta. It's like a snap. Bad data. Okay. How to make this one to your a graphics file? I think I can do it from here. Save as, and I can actually save it as portable network document bitmap file formats. Exercise 1 and 6 PNG. If you put there the extension, then it should actually save it in this format. Yeah, just for fun. Let's see if it opens well. Yeah, looks like that. And next step would be to insert the figure there. Have you been editing the anything with the Google Docs? Probably you have. But the simplest way of getting that document there is, let me first find it. Is it here? Yes. Okay. Easiest way is to just take it from here. Take it from here and just drag and drop it somewhere in. Not there. I usually have more windows here. Well, you can Control C and I think you can Control C, Control V. No, it does not work. Oh, okay. I'm actually editing here my own exercise 1 file. That shit happens. All right, so I can insert the image. Upload from computer and their documents of the exercise 1. That will go there. You can also drag and drop it directly from file browser to this document. Okay, not that bad this far. Let me do something. I'll continue then editing my copy. All right, so I have the stem plot there. Next sequence, try to figure out how this sequence actually will be generated. So sequence X1. Going little by little in the mode that you will work on your own answers. So what I'm looking for is the figure of that data sequence, which looks more or less, okay, what, -4, -3, 0, -1, 1, okay, dn plus 1 is here. This advanced operation happens before time 0. Then we have 1.2 times delta, and then we have the delta n minus 1. So the data sequence should look like that. I'm looking for the figure. Delta n plus 1, delta n minus 1, and that is 1.2 times delta n. Yes? Mm-hmm. Yep. Yes, you had actually quite high frequency. Yes. Yes, that's correct. Yes. Yes. Copy that. Copy that here. Now you can see some comments. Okay. Yep. Then the next different sequence. Let's template. No, 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 not double. Those actually. You need to change that one to that it tests if that is 0 or not. So delta function, delta, not the index directly, but the delta. So basically, that test is same as if n equals to 0. Got it? Yes, you got it. Excellent. Yeah, and next, just move on. Start doing the next. Mhm. Third one. Okay, did you figure out the next one? Generate data sequence results in that. Yeah. 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 That's why I told you. Move on. That's wrong. Do some work, more work. Hey, whatever. What did you generate that easy? Oh, yeah. See, that is your problem. NN. Why you are doing that NN? It's supposed to be the delta of NN. Not NN itself, but the delta function. Hi, please welcome, join us. More the merrier. Oh, okay, yeah, fine. Just take a seat anywhere. And the first thing is to start installing the Octave on your computer. And at some point, you need to also try to install the MATLAB. It seems that it takes for a while before you can get the get either of those working. Tomorrow we'll try with the MATLAB, but today we still work on Octave. So put first the Octave package there. Yeah. Oh, by the way, yes. I'll show you the. That's the homepage of the course, which is also the LIA system. I think I put the link to the. Yeah. Yeah. There's supposed to be the link to this. or you can also just click on that QR code there. Mhm. So show me the plot 8 plot. Okay. Yep. How about the 9? Next one. Oh, you haven't done it yet. Oh, okay. Yep. And then what is the next question there? Oh, I need to show you that one. Yeah. Yeah. Let's wait for first. You can stop thinking how to do the next. Yeah. What is the remedy? It's there. Okay, so yeah. Your this is different size from and now you have invalid handle. So close the graphic. Yeah. Click close all. It should do the same thing. But there. Mm, oh, zeros. Hmm. Ah, okay. See Does nn greater than equal to 5 and less than minus 2. Yeah, so you have missed the it's opposite direction. Comparison is opposite. All right. So got it. Good. So how far are you? Almost there. Demo. Hmm? Ah, yeah. So it just took for a while. Yep. So what's up? Yes. Indexes, yes, and then yeah, you know it doesn't. No, it doesn't. Yes, there is. Easily. Actually, you can test if in. Okay, there are plenty of ways to do it. One way, generate something that starts from -2 and forward. Then you actually make another one which starts at 6, yeah, and forward, and do minus of those. So you have a advanced step function started at -2, and then you basically turn it off by subtracting a delayed function. That's one straightforward way. I think that's I think we don't need that one. You didn't need that package. Load that package. Control and signal, but I think they are already there. Yeah, package list. So PKG list, but now it's doing that one, so it takes for a while. Try Control C that one. Doesn't work. Okay, kill it. Kill it. Start over. do the like it's a list. Mm-hmm. Control and signal are there already. Good, good. We are all good. Yep, make your own copy. Okay, okay, good. Then write your name there and basically start filling the gaps, missing information. Well, there will be actually the YouTube video, really crappy and lots of empty spots and confusing and. But anyway, you didn't miss anything. It has been lots of pauses and confusing also in here. Yep. So.
Do I write down this?
Yeah, that's yeah.
And then stamp for all 3 comments?
Sure. Yeah.
Okay.
Yeah. That'll work. It can also have these things, or actually you can get it without those the markings from the from the history command history. Doesn't matter. No. What? What's happening? Strange. Strange things happen. You should let's see. You asked you to insert actually the figure there. Yeah. Yeah. Save it as PNG. Just write the ending PNG for the. So PNG stands for Portable Network Graphics. Makes sense to use those on web. So have you figured out that one yet? Oops, sorry. Okay. It's not that hard actually. So you have the sampler rate. Okay, which means that you know the sample time. Then you have that many samples, meaning from 1 to that number. So those are the indexes. And then you have the frequency there, amplitude. Only thing is which requires a little bit of calculation is the some random noise. But the sinusoid part you can already do. It's the same as on previous we did here with different indexes and different sample rate, different everything. Those numbers are changing.